Welcome to today's Explainer. Today, we're jumping right into Stephen Witt's fascinating piece, The Thinking Machine, to decode exactly how NVIDIA became the absolute indispensable backbone of the modern AI revolution. Look, if you've glanced at the news lately, you know artificial intelligence is completely reshaping our world. But behind all those mind-bending software algorithms, there's a physical reality, a foundation of silicon making the whole shebang possible. So today we're unpacking the definitive story of how one single company positioned itself to build that foundation literally years before the rest of the world even saw it coming.
Okay, let's just pause and talk about this number for a second. NVIDIA recently hit a jaw-dropping $3 trillion valuation. $3 trillion. To put that into perspective, it's honestly one of the wildest business stories of our time. Why? Because this is a company originally founded to make video game graphics. They weren't setting out to build a digital brain. They just wanted to render millions of 3D polygons super fast so digital explosions in your favorite games would look, hyper-realistic. But here's the crazy part. By obsessing over the intense math required for gaming, they accidentally created the exact hardware architecture that now powers all of modern artificial intelligence.
And as we look at their timeline, their evolution over the last 30 years is just a total masterclass in relentless focus. They started way back in 1993 with highly specialized gaming hardware. Then they made this massive bet-the-company pivot in 2006 with the launch of the CUDA platform, which, don't worry, we're going to unpack in just a minute. Fast forward to 2024, and boom, they stand as the world's most valuable enterprise. It's a stunning chronological journey of anticipating a future that nobody else saw coming.
So here is the roadmap for today's Explainer. We're breaking this down step by step. First, the $3 trillion origin. Then, the CUDA parallel revolution. Next up, leading with productive paranoia. After that, we'll look at their existential threats and risks. And finally, we'll wrap up with 10 lessons for the future. Let's get right into it. Section 1, the $3 trillion origin. Let's start by looking at the massive strategic bet that laid the groundwork for this entire financial empire. Back in 2006, NVIDIA's CEO, Jensen Huang, made a move that absolutely baffled Wall Street. Completely confused them. He poured a decade of time and massive resources into launching CUDA, which was a software platform built specifically for researchers. But here was the catch, and it was a big one. He was building it for a market that literally had zero customers at the time. Analysts famously mocked it as a $0 billion market. Just imagine going to your investors and saying you're sinking billions into a tool for a customer base that doesn't even exist yet. Unsurprisingly, NVIDIA's stock took some massive hits during this period. Wall Street thought Huang was basically setting money on fire. But Huang, he was paying attention. He noticed that a few researchers out there were already trying to hack gaming chips to run complex math, and he simply decided to build a platform to make it easy for them. This wasn't a quick flip. It was a grueling 10-year bet on future demand that required an almost irrational level of conviction. Moving on to Section 2, the CUDA parallel revolution. Let's see exactly how this bet turned into the technological breakthrough that fundamentally changed computing. Now, to understand why NVIDIA is so special, we have to look at the architecture. Traditional computer processors, or CPUs, act kind of like a single-lane highway. They process one task at a time. Now, they do it incredibly fast, for sure, but it is still sequential, just one car after another. But NVIDIA's graphics processing units, or GPUs, they operate completely differently. They're more like a massive 1,000-lane highway. They can handle thousands of smaller tasks all at the exact same time. This is what we call parallel processing. Originally, this parallel approach was just perfect for rendering thousands of pixels on a screen simultaneously. But those researchers we mentioned earlier, they realized that this 1,000-lane highway was also precisely what was needed for doing complex matrix multiplication and running deep neural networks. And that realization changed everything. That parallel processing architecture transformed their hardware from a niche research tool into the absolute mandatory platform for all deep learning. When the AI boom finally hit, scientists realized that training an artificial intelligence requires billions of simultaneous calculations. That is something a traditional CPU literally cannot handle efficiently. But NVIDIA's hardware, it was exactly what AI needed to learn. And because Jensen Huang had spent a whole decade building the CUDA software to interface with those chips, NVIDIA ended up being the only company on Earth ready to supply the picks and shovels for the AI gold rush. Section 3, leading with productive paranoia, because behind this incredible tech is a truly fascinating psychological approach to corporate leadership.
Jensen Huang's management style is, well, it's notoriously unconventional. Get this, he personally manages over 60 direct reports. Now, in traditional corporate America, managing more than maybe 8 or 10 people is considered way too broad a span of control. But Huang operates without a designated number 2. He maintains a radically flat organization. Instead of vital information filtering through layers and layers of middle management, where bad news almost always gets sugarcoated, all 30,000 NVIDIA employees submit weekly top 5 priority emails. They aren't writing long, polished corporate reports. They're just firing off their 5 core priorities and biggest challenges directly to the top. This system is brilliantly designed to accelerate truth and entirely bypass traditional hierarchy, ensuring leadership is always plugged into the actual, unvarnished reality of the business.
And he grounds this incredibly flat structure in what we can call the fear principle. Huang notoriously treats the constant threat of disruption not as some negative feeling you need to hide away, but as vital data to fuel urgency. He actually reminds his staff, constantly, that they are always only 30 days away from going out of business. By operating under this productive paranoia, the entire company culture is geared toward moving fast and staying hungry. It turns out that fear, when you harnessed it correctly, is exactly what keeps a wildly successful company from falling into that fatal trap of complacency. Which brings us to Section 4, existential threats and risks. Because if we take an objective look at the source material, it reveals that even a tech behemoth like this faces massive, unresolved vulnerabilities. Seriously, ask yourself, when you are a company worth $3 trillion, what could possibly bring you down? What is your greatest weakness? Well, the answer comes down to geography. You see, NVIDIA only designs their chips. They don't actually build them. They rely almost entirely on a company called TSMC, which is located in Taiwan, for the actual manufacturing of their most advanced hardware. As Stephen Witt outlines in the text, this creates an extreme geopolitical choke point. Any global instability in that specific region presents a literal existential threat to NVIDIA's supply chain. Just think about that. A $3 trillion digital empire is entirely tethered to the physical security of a single island. It is a completely unprecedented and frankly unresolved vulnerability in modern business. And compounding that physical vulnerability is a huge internal one. The company's future remains a major unknown risk simply because it is so heavily over-indexed on one visionary founder. Jensen Huang is so deeply tied to NVIDIA's identity, its culture, and its strategic vision that right now there is no clear succession strategy. When a company's roots all trace back to a single individual, transitioning that leadership eventually becomes one of the most perilous hurdles a business will ever face. Finally, Section 5, 10 Lessons for the Future. As we wrap up this explainer, Stephen Witt distills this incredible, high-stakes journey into some really clear, actionable takeaways. These 10 insights beautifully summarize the NVIDIA playbook. They show us how long-term platform thinking, like that grueling decade they spent working on CUDA, almost always beats short-term product thinking. They highlight how flat information flows and productive paranoia really do accelerate truth within an organization. And crucially, they point out that hardware is the new software. For years, Silicon Valley obsessed almost entirely over code and apps, but NVIDIA proves that owning the foundational physical layer is where the true, unassailable power actually lies. Plus, recognizing that your supply chain is inextricably linked to geopolitics, that is just non-negotiable today. Really, these aren't just lessons for tech companies. These are blueprints for building any resilient organization in the 21st century. But we absolutely cannot leave this topic without addressing what is arguably the defining civilizational challenge of our era. The chips NVIDIA builds are increasingly powering artificial intelligence that makes real-world decisions that affect you and me every single day. Which leaves us with a profound final thought to chew on. As this technology scales exponentially, all built on the back of these incredibly powerful thinking machines, can humanity actually solve the AI alignment problem and ensure these systems share our human values? It's a massive question we all need to be thinking about right now. Thanks so much for joining me on today's explainer, and keep questioning the world around you.